Alright, so now we're in 2.5 where we're modeling direct variation. Direct variation is a concept where the variable y varies directly with x, and it comes as a general formula of y equals a times x, where um, x is in the numerator at all times, and a is what is called the constant of variation. In other terms, if you were to graph it, that would be considered our slope. The difference between direct variation equation in slope-intercept form is that there's no need for the y-intercept in direct variation because the y-intercept is always 0. So there is no b. There's no need for having uh, a b in the equation if it's always going to be 0. And there are some stipulations that, if you look here, what do not make a direct variation. So if x is in the denominator, then it's not a direct variation. If there's any addition or subtraction which would make the y-intercept be another value other than 0, then it's not a direct variation. If there's any type of exponents, square roots, powers, absolute values, any other symbols that can be attached to um, our variable or other values there, then it's not a direct variation. So if they ask you, is something a direct variation, one of, just by looking at a term, if it does not fit any of these criteria, then we can say that it is a direct variation because these are stipulations on what does not make a direct variation. Granted, once you get y by itself. So for this example here, I want to write and graph a direct variation equation from graph through point 5 comma negative 1. So if I'm going to go to 5 comma negative 1, first I'm going to plot it. So I'm going to go to the right 5, 1, 2, 3, 4, 5, down 1. So this point right here is at point 5 comma negative 1. So if I were to graph this as a direct variation, I remember that my y-intercept is always at 0. So there it is. Now if I were to graph this, I'm just going to connect the points. And what I'm going to do is I know that my direct variation equation is y equals a over x, where a is actually our slope. So let's take a look. So I'm going to go y equals, and my slope is, I'm going to go down 1, so that's a negative 1, over to the right, 1, 2, 3, 4, 5. So my equation for this particular point is that y equals negative 1/5 x. Next thing that we're going to ask in these examples is that we know for a fact that x and y vary directly. I want to write an equation that relates x and y, then find y when x equals 24. So there's going to be two parts, one of which I would need to write an equation. Second part is I want to find out what y is when x is 24. So for A, I have x equals 3 and y equals negative 6. So I know that if x and y vary directly, that means that my x equals ax equation applies. For example A, I don't know what A is. But what I do know is I do know what x and y are. I know that x is 3, and I know that y is negative 6. So I'm going to substitute in those values in for this equation to solve for A. So I'm going to say that negative 6 equals a times 3. Now I want to solve for a, so I'm going to divide both sides by 3, which then gives me negative 2 equals a. Okay, so now that I know that a equals negative 2, To rewrite this as an equation, I want to substitute in negative 2 and for a into this equation. So now I have y equals negative 2x. So that's the first part. Second part is I want to find what y is when x equals 24. So now I'm just going to substitute x as 24. 24 times a negative 2 gives me a negative 48. Okay. Same thing goes for b. I'm going to still use the y equals ax equation, but I don't know what a is, so I'm going to substitute in my x and y. So it's negative 2/3, which is my y, equals a times 1/9. So now I'm going to solve for a, so I need to get a by itself. So I'm going to multiply both sides by 9/1. So this cancels, which leaves me with a equals a negative, so that's what, negative 18/3, so that gives me what, negative 6. So then my first portion of it, it's going to be y equals negative 6x. Second portion is now I need to substitute x into 24 to find out what y is. So my y here would be negative 6 times by 24, which gives me a negative 144. Okay. Last examples here, I want to tell whether the values show a direct variation, and if so, I want to find the constant of variation. So this here, they're looking for what is a in the whole y equals ax form. That is, a is the constant of variation. So looking at these two graphs here, you need to pay attention to the x value and the y value just below each other. So those play critical roles. So the first portion one is I want to find what negative 2, what value a I need to get for it to be a 1/2. Okay, so if I were to multiply, say if I were to multiply this by negative 1/2 here, multiply by negative 1/2 here, these cancel here, which gives me a equals a negative 1/4. So negative 2 multiplied by a negative 1/4 gives me a positive 1/2. And so what I have to prove is in every single one of these boxes, that x holds true for that exact a. So what I mean is does negative 1 in the second one, if I multiply that by a negative 1/4, will it equal 1/4? Yes, it will. So if I have 2, multiply that by negative 1/4, will it equal negative 1/2? Yes, it will. If I go 8, multiply it by negative 1/4, will it equal a negative 2? Yes, it will. And then 10, multiply that by a negative 1/4, will it equal a negative 5/2? Yes, it will. So it would hold true in every single one of those x, y values. So as long as it holds true in every single one of them, I can say with full confidence that it is a direct variation, and the constant of variation is that value you multiplied it by. So my a here would equal a negative 1/4. Okay? Looking at b, the first one is negative 3, and if I multiply that by 2, that gives me a negative 6. So that holds true. Negative 4, multiply that by 2, gives me a negative 8. That holds true. Negative 5, multiply that by 2. Does that give me a negative 11? It does not equal a negative 11. So the attempt at saying that the constant variation for this graph would be 2 would be incorrect. So, and since I'm having inconsistencies with the constant of variation, I can say that this is not a direct variation. Okay? And that is being able to apply models using direct variation. Hope this helps. Till next time.